Wooly.
What is going on? How you doing, Bill?
So I'll let you do your own intro and whatnot, but for the record, I've known Mike for a long time, and we both worked on the security track at CodeMatch, which has come up a number of times now in this, for some reason, well, not for some reason, it's for good reason. In this particular roundup, I was asked a number of years ago to kick off a security track for them, and Mike and I were working on a project together, and so I asked him to do some stuff. He set up a capture the flag competition for developers, and then we went 2 or 3 years like that. Then we swapped, and he put together the speaker track, and I ran the CTF. And now we have a completely open source CTF and bring in just top-notch security speakers, thanks to Mike's community involvement and engagement with the whole security community, application security, network security, operational security, risk management, the whole deal. So very much looking forward to seeing what he's got here as far as putting together reports. We talked about how to use with Simon, we talked about how to use the API to generate scans in an automated way using whatever your CI/CD process is. Well, now Mike's going to give some breakdown on how to get some data out of there that's actionable. So, Mr. Woolard, take it over.
Thank you very much.
See you at the end.
Alrighty. So good morning, everybody. Good afternoon. And I know there's some folks on here from Europe, so good evening to you all. Thank you for joining me and sticking around. Hopefully you're all staying safe. We are in some unusual times here. And, this is my first pandemic talk, if you will. So it's a little unusual not being up in front of everybody and being able to deliver and having that direct feedback and interaction with the crowd. A little bit about me. I work in the InfoSec and compliance space. The team I manage is broken down into 3 silos, but all work together as one. We have our engineers who are responsible for the infrastructure, networking, endpoint security. We have our compliance team, which handles all the adherence to various standards and that we certify the company against. And then finally, we have this application group. It is responsible for reviewing the architecture from a security standpoint and just the basic security posture of the web applications the company builds. This group runs the tools like ZAP, does the assessments, does the automated scanning, the manual scanning, pen testing of the environments that host our applications. So it's a little bit about the work I do. How to contact me. I'm always on Twitter. I always check my Twitters. I have my DMs open. This is the most probably reliable way to get a hold of me besides email. I used to live and breathe InfoSec Twitter. I would learn so much information, or at least where to go get it, and it would be so immediate. Hoping one of these days it will get back to that knowledge share treasure trove it once was. But you can also reach out to me on LinkedIn. I generally don't accept friend requests for people I don't know, don't work with, that type of stuff. But you can still chat with me via the messaging tool. Finally, the Python script, the thing that's actually controlling the automation that I'm going to be talking about today, is available on the WordPress blog here at the bottom. I use this blog for just content related to my talks and Pluralsight courses. I will get into the script in a little bit later, and when I do, I will redisplay this link. So if you want to go grab it now, go for it. But the link will be available once we get into that portion of the talk. I also throw the slide up at the end here, so you'll be able to grab it there as well. I just mentioned that I am a Pluralsight author as well. I have authored a few courses on, speaking of compliance, ISO 27001. There's a prep course if your company's looking for a good framework for security. It's a 27001 is a framework that's bigger in Europe than it is in the US, but with all the privacy laws that are starting to come, CCPA, for example, in California, you're probably going to see a lot more of this popping up here in the United States over the next 1 to 5 years, really, around privacy law. So a web application test course, which was based on OWASP and the secure testing guide. And then the final 2 courses is more related to what we're going to be talking about here today. One is more of a beginner course for OWASP ZAP. And then I have another course that is being pushed out in 2 weeks, or maybe 2 weeks, talking about automating ZAP with Python. This talk is basically a watered down version of that course. Today, I will talk at a high level. Simon already gave you a lot of the good detail on how to automate ZAP in the command line and controls of ZAP. We talked a little bit about the ZAP API. But in this course there, and then in this talk today, I'm going to take that API and build a system around it to take advantage of the power behind the automated scans. One thing I want to make very clear, though, just because I am writing these courses, doing these talks, I am not pretending to be an expert on anything. You sat through a very clever ZAP automation talk earlier with the man in charge of building it. And if Simon's still on checking this talk out, please feel free to jump in at any time to clarify anything. That's the man. And when I found out I would be following him today and the topic he would be speaking on, I basically rewrote my entire talk. I literally spent the last 2 hours kind of tearing out different things from this talk that he already talked about. So hopefully this talk is just more of an extension of his talk. Hopefully the flow still goes well. There was a couple things that he did talk about that I didn't want to repeat. So I have pulled those items out. But I am going to focus on the options available to you in ZAP like he did and only touch really get into the implementation part of it and help you understand that more in detail. I transformed this talk into like a knowledge of that you learn from time and putting some structure around it and implementing it. So this is more of like a use case talk and how to actually implement ZAP automation. There are many ways, obviously, to implement it and a lot of functionality in the command line options and the daemon of ZAP. But this talk will cover the use case and how we automated active scans to solve a problem we had at work and wrap that solution into an open source tool that we've been developing in-house and will eventually roll out to the public consumption. But I'll give you a sneak peek here. As for the tools needed to pull this off, I'm going to run down the minimal set required to run the automation needed to follow this talk. I threw the version numbers in there as reference, but you don't really, don't think there's anything there that will break anything if you're not using the version numbers supplied here. You will need a Windows or Linux server that can be running either permanently or during the hours that the scan is scheduled for. And the system will not need to be very heavy. We're talking 4 to 8 gigs of RAM, 2 to 4 cores maybe to be sufficient. System specs will impact your performance. So depending on how many scans you wish to run per day, you may wish to add more resources. Now, to set the automation system up, you'll need to have installed in the server Python, which is currently on version 3.91, and run the script that we'll be creating. Python is the brains of the operation, as I mentioned. You're not going to have to write the script from scratch. I am providing it to you. But if you want to do any types of edits, I mean, that type of stuff. So next, the host of the party, right? The latest copy of OWASP ZAP, which is currently on 2.10. We built all this on 2.9, so it's definitely not version specific there to 2.10, but that is the latest, which I believe just came out in December. And then the next 2 items are optional based on your setup and needs. The way we're setting it up, I have a database system to manage the information behind the scans. In the scripts applied for this talk, we will be connecting to a MySQL 8.0.23. You definitely don't need MySQL. Any database system will work that has Python library with the connection. And then the last item on the list, and something you probably want to install on a laptop, works just fine on the server, but you will want to customize and edit the script for your business. So a text editor of your choice. And if you don't already have a commercial solution, Notepad++ is simple, free, and easy to use. So that's your basic set of tools that you're going to need here. So where to start? So the thing I like most about my job, the InfoSec industry specifically, and hacking in general, is the problem solving that goes into it. I went to school for a CIS major. I covered logic, covered algorithms, covered coding. And when I say coding, remember we're talking the late 90s, so assembly language, C, COBOL, VB6. At the end, we started getting into C++ and Java a little bit, but I ended up taking on an engineering admin type of job out of school. So at the time, this major did nothing more than really certify my geek status. But over time, I took a lot of those tedious tasks, those complicated tasks, broken tasks even, and I relied on my coding background to solve the problems there, right? I used coding as a tool rather than a title. Now, I wanted to say that because if you don't like my script, it's not going to hurt my feelings. I'm not a coder by trade. I use it to solve problems, to simplify my job, right? Now, I mentioned I had a problem to solve. My company has built a few dozen applications, APIs, components, and services to support the industry we work in. And at the time, we were operating under this waterfall methodology, which I'm sure you're all familiar with. lots of structure, gate after gate workflow, and a defined maintenance window for releases. Every Wednesday we cycled through the apps that were going to go to production on Thursday and ran some various automated and some manual scans in QA with our ZAP tools, with others, more commercial type tools as well. And we spit out the results to be incorporated into future sprints or whatever they were called for waterfall. But, it was a very clean and orderly process. Well, then came along Agile and disrupted all the security processes we had built into the SDLC process, right? The company itself was moving into a period of fast growth, and all while we were trying to implement this new security scan process and procedures, we were also trying to bring on new acquisitions, and not just local, but international ones. The problem is, bringing on companies with multiple applications and development teams of their own, some of which had poorly defined security practices. Companies coming in with waterfall practices, some were agile, I'll admit, but some were even like developer runs the show, where the developer did the planning, did the coding, did the testing. They also managed the infrastructure, and for good measure, they managed the deployments, right? Really was throwing the defined process for a loop while we worked to integrate the team. Keep in mind, during all this, the responsibility to handle all these security assessments, consulting, and pen testing fell onto one person on my team. At the time, we were organizing a lot of our work in spreadsheets, so we decided to take a step back and build an application dashboard around this. We needed a way to gather all the information about the applications up front, details of the infrastructure, architecture, data, know who to talk to, track the findings through to mitigation, and so on. This here, what you're looking at, is the index page for the homegrown tool, my baby, that we've been looking to develop into a tool that we'll put out there for the public to consume. It's basically the graphical interface for the ZAP automation that we're going to be talking about. To develop this tool, I have a small team working on building an application framework, which we would then release to the public and allow folks to build add-ons and connections to supporting tools that can be integrated into the dashboard. The idea is to build a one-stop shop dashboard to manage your applications. Now, one of those integrations we have built already is the ZAP API. The tech owners of the applications see what you see here, but they're only going to see the scan button on the right-hand side here of the application they maintain. So a simple click of this button will open up drop-down. They'll allow you to select the environment. The environment that you see in the drop-down list is tied back to the URLs we've collected about the application. So they're going to select the environment that they want to scan, and they're going to hit the submit button. The relevant session is loaded into ZAP, which is sitting on a server on the network. A spider is kicked off by the active scan. We then use the API to retrieve the detail of that report, and the individual findings are loaded back into the tool, the security scan dashboard page of the tool for review and mitigation. So I'm going to jump into that now to take a little deeper look at this process. So here we're looking at the details page. So after the index page, you drive down deeper into the details page. And as you see here, it's rather detailed, right? You don't get lost into the information overload that you have on this page. It's not important to the talk today, but as you can see, there's a lot of information captured here, and some of it had to be manually inputted. Platform details here at the bottom. This will show you all the infrastructure details that may need, a security assessment. There's another example of a manual entry is the pen test details button, where you're capturing the details you want to reference when engaging third parties for an assessment. What I'm trying to do is get to a point where as little information as possible is entered into this tool, and instead the information is supplied via an API integration. So making this tool a central repository, if you will, of information about your application. One of the integrations you may want to look at is with your static code analysis tool. In this example, we're using SonarQube, which some of you may be familiar with. Then back on the details page along the right-hand side here, we have our integration with a ticketing system to monitor in graphical formats the uptime availability, incidents, problems, and through integrations with some of our DevOps tools, we see the releases tied to that application. Now, this is a ZAP talk, and maybe at the end, if there's some time, we'll take a look at a little more at this tool. But I mentioned how we requested a scan on the index page. We can then retrieve the findings from that ZAP scan here at the Security and Testing tab at the top, which opens up our tracking tool for all the findings about our application. On the left, we have our reports button, so we can see all the reports from the various web application scans that kicked off, as well as the findings from those reports down below here. The items at the very bottom, the items that have the Adobe icon here on the left, these were the reports from before we were able to set up the ZAP process. All the information had to be manually entered from the reports. And when you click on one of these links, it actually takes you to the report that they came from. Now, good detail in the reports, but the manual process adds time, and that's time we didn't have. That was time we were trying to get back. So enter the ZAP API. When I click on the ZAP API, I should say a finding from the ZAP automation, instead what we're getting is, we're able to grab all the information from the scans systematically through the API and store those details into the database, available on demand, and do this completely hands-free. So while I'm here, one other thing I do want to talk about real fast. On the right-hand side, we have our endpoint security scanners that we run weekly that scan all of our endpoints in our testing and production environments. We then have a table set up that connects those endpoints back to the application. So I can see how those vulnerabilities in the endpoints, whether that's a web server, a database, or some other type of service that affects the applications running on it. This is one in particular has a certificate issue that you see here. And so when I go back to that details page, what I'm able to see in the tech debt section here are what vulnerabilities are on that endpoint that affect this application. So including the callout that the application is supporting a TLS protocol. So it's pretty cool stuff. So you see, from the index page, where the product owner, developer, whoever is associated with that application, they can hit a scan button. They can select the environment to scan, and within 15 minutes or so, the details of that report will show up here on the details, the security testing details page at their fingertips. So jumping back into the illustration, we were just here at the dashboard. This is an optional piece, but a piece I've implemented to help automate my work. And it's obviously central to the way I use ZAP automation in this talk. Next, we're going to jump over to the database and see exactly what happens when you click the scan button on the dashboard and submit a request, and how to store those findings after. From there, we're going to take a look at the ZAP setup to pull this automation off. And finally, we're going to check out the fancy script sitting on a central server that makes this all possible. I do want to point out that the script I will provide is customized for a specific use case. Be sure to check out the ZAP website, that's zaproxy.org. Click on the documentation tab at the top and review the API details provided to learn more in depth about the calls of the script, as well as what else is available to you. So I'm going to be covering what we use in order to get this up and running. There are a lot of other endpoints out there that you can make calls with and do a lot more fancier things than we use it for. All right, so the database. What you see here on the screen is the minimum required to set the table for the script provided. It's pretty light and straightforward. The URL is the address of the site you want to scan. The date and time field holds the information when the scan will be ran. Pretty easy to understand. The two fields that aren't as obvious are the ZAP name, which is the name of the session ZAP will import. The ZAP session contains all the URLs in scope, the authentication parameters, a script of its own to log into the site, and the basic configuration ZAP needs to understand how you want to scan that site. The state column field holds information on the status of the scans. So each requested scan will be dropped into the table as a ready state, meaning that once the requested date and time of the scan hits, the scan will kick off. Once that scan kicks off, the status will be updated to in progress. And then from there, it's either completed successfully or crashes with an error. It happens more than I like, but updates the field accordingly. You're going to hear me repeating this a lot throughout this talk, but you can customize this accordingly. So if you're planning to add any additional functionality, go right ahead. It's all yours. It's all out there on that WordPress site to grab. For one of the examples here in the dashboard, there is a form our product owners can fill out to request a scan during off hours, nights, weekends, holidays, right? On this form, they can include the group that the report should be delivered to, additional notes. We also grab some who requested the scan, who approved the scan, and who the tester of the application is if it's not the automated scanner. So the table I use is a little bit more detailed than what I previously showed you and what I've provided you, but because I do have that extra criteria of the scan. So that was the table for requesting a scan. I mentioned to you, you can also use the API to retrieve information on the findings of the scan. So an optional table, if you want to pull the findings from ZAP API and store them in a table, this way, instead of pulling up a generic HTML report, you can make your own custom report for the findings, or as I showed you in the dashboard, an area to manage the findings in lieu of a report. Now, most of the columns shown here are the various pieces of information supplied by the API. And like I said, you can update this accordingly if you plan to add in the additional functionality. So not much is needed in the database. In fact, this is an optional step all around. I implement it because my company manages so many different web applications. We have that dashboard that ties back to a database. But also because I don't have the scans integrated directly into a DevOps tool directly yet. That is my next phase of this and something I may talk more in depth about in the future. But for now, we still require the request to be made to schedule the scan. So let's jump now to the end here and discuss setting up what is needed in ZAP to allow the script to automate it. So there is really only two areas I need to touch on because Simon did a very good job this morning talking about everything else that I've now since pulled out of this talk. I have two things that I still need to cover though. One's simple, one's a little bit more complex. I do make some assumptions here, though, on your knowledge of the settings of the tool. That controls things like the spider options and active scanning. With that said, there is a vast knowledge base on the ZA proxy website. There is also some free training videos on the ZAP website as well. You'll see a bunch of ZAP in 10 videos Simon put together with the all-day DevOps group. You can always check out my Pluralsight course on getting started with DevOps with ZAP as well. I have actually up here, I could show you. So on the ZA proxy website along the top here under the videos, we have all those links that have all the various training courses or videos that Simon has put together. And then under documentation, you have your API details. A lot of good information here, a lot of good detail along the left-hand side. You can just select what you want more information on and get it there. But once ZAP is opened, under the tools, then options is an API menu item. If there's not already a key in there, you're going to want to generate a key and save that, which we'll need later on. Keep in mind, if you use ZAP API for anything else, don't generate a new key. It will break your other implementation. Just copy and use the key supplied already. Now for a more complex topic, ZAP sessions. And now when I say complex though, I just mean that it's more complex than hitting a generate button and copying and pasting a password, right? Or a key, I should say. The session and associated context is a function built into the ZAP that is more or less a recording or a database of your scanning preferences for any given website. Upon entering ZAP, you are asked if you want to persist your session. By clicking yes, you will save your workflow or your work, allowing you to quickly repeat any scan without the pain of setting up the tool again. These sessions are then stored in the session folder inside of where you installed ZAP tool on your machine. One thing I do want to note here is if you do hit no, you are able to save your session later on. So it's not a make or break decision here right off the bat. But taking a closer look, and really the only part to focus on is the context inside the session. Everything else is pretty much going to be cleared out through the API before each scan to give us a fresh set of results. So the author in me really wants to walk you through step by step how to set up a context, but we really don't have time for that. So the 2-second lesson to quickly get in there and set it up, if you already have the proxy turned on. If you're already starting to pull in the various URLs to the tree, you can right click on one of those and add it to a context. Or if you set it up from scratch, you could double click on the default context to open up the properties window you see here. Or just above that, there's a little button with a green arrow or a green plus sign that will create a new context for you. Now, the 3 items I would like to spend some time on inside of the session properties, because they give you the most bang for your buck, is your include in context. This tells the scanner which URLs are in scope. The technology tab, because setting this up properly can speed up your scans. The technology tab kind of defines what technologies are used, what databases, what kind of code, what is all used within that application you're scanning. And if you know these answers already up front, you can uncheck everything else. The ZAP scanner won't waste time scanning that web application for things that aren't there or knowingly not. Finally, the authentication. Because the scanner won't get very far if it doesn't know how to log in, there is forms for logging in. There is scripts that you can build into this, a Zest script that you can build into this to automate your login process to make it very easy. That's the way I recommend doing it, especially if you have a more complicated login process that may use some type of SSO or some type of third-party tool that comes in and controls that IAM process for you. If I were to add a 4th item to the list here, it would be that exclude from context section as well, simply because there might be areas of your application you don't want to touch. Something that may kick off 1,000 emails, a password reset or some type of admin function you don't want to accidentally touch. So there are ways of excluding using that item as well. But I would refer you to the ZAP help screens and documentation for more info on all this. This is also covered in detail during my Pluralsight course. So, once this is filled out, you can save or persist your session for ease of use. I recommend saving your sessions into the default folder so that the API knows how to find it without any additional coding. But that's pretty much what is required inside of ZAP. Not all that hard really. With ZAP set up and ready to accept calls, the last thing we'll look at during this talk is the Python script that will control this automation. At the bottom of this slide is the link again, if you're interested in going out there and grabbing it now. But just to make sure we're all on the same page as to what is going on here, and in case there are any questions of what we're doing here, I have a central server on the network. Doesn't matter if it's Windows or Linux, but basically you'll be setting up a scheduled task at an interval that makes sense for your business. This task will fire off a script, and that script is what makes the API call to import the session context, spider the site, and kick off the scan. Now, on the diagram, I show ZAP off to the side here, but in reality, in my setup at least, this is all on one server. Nothing's to say that the database can't live on that same server as well. This is all optional to how you want to set it up. Now, one thing I want to point out is ZAP needs to be up and running on the server. Whether that's the GUI or the daemon, shouldn't matter, I don't believe. But Simon referenced this earlier, that starting ZAP with the GUI up gives you the ability to see what is actually going on. So when I actually kick off these scans on the server, I'm going to be able to see that context get imported, the session opened up, the context get imported, the spider kickoff, the active scan kickoff. If there's any issues throughout that whole process, I'll be able to see directly in ZAP what is going on at the time that there was a problem. So I definitely recommend having that GUI turned on, at least for the first couple weeks, if not months, that you're running this. To save resources, it's fine to run this in daemon mode and in the background through a command line. The script is going to call into the database to see what needs to be scanned. And then it's going to call out to ZAP through the APIs to scan it. And the cron job or Windows cast scheduler is going to force this action at a predetermined interval. So that's that. Let's dive into the script a little bit here. Hopefully you've grabbed it by now if you want to follow along. This is not a development class. I'm not going to go through this line by line or any great detail here. Because I am giving you a script, I feel it's important to help you through what some of these sections are and what you need to update to make this script work. So I've already provided you the script again, and I will provide it at the end of this talk, the links for it as well if you haven't grabbed it by now. So maybe just follow along. We're dealing with the Python script. which means you'll need a little background in basic coding frameworks if you're going to customize it and run and implement it. Even though this isn't a Python course, the next couple slides, I want to break down the different sections of the script to help you understand how it interacts with that API. So the first section here at the top is the import modules needed to perform certain tasks. Obviously, the date and time, we know what that's for. The sys library gives you the access to the arguments being passed in. But the two I want to focus on here are the requests and the MySQL connector. As I mentioned before, you do not need a MySQL database, but you will need to install a library of the database of your choice once you have settled on a solution. And the request module is imported in order to help with the HTTP requests that are made to the ZAP API. Now, I call these two out because it's not a simple import as you see here. You will need to pip install them with Python on the server first. So in order to import them into the script, to avoid any confusion, this is performed outside the script. So directly in the Python integrated development environments is where you'll do that. Global variables section. This is where we set up and configure the communications performed in the script. The ZAP API key is where you set up the key you pulled from the ZAP options menu we talked about a few minutes ago. The ZAP host is where you have ZAP up and running and the port it's listening on. So these are two options you can always change. And this is why I said you technically don't need to run ZAP on the same server as the script. Just makes it easier. One thing I will point out is if you do have it set up on the same server, but you're not using the port 8080, you want to change that to whatever you're running inside of ZAP. The database settings connected to the database log you in and tells the script what table to pull from. I did drop the database credentials directly into the script, and although not ideal, if you don't use some type of central vault to call into and lease your credentials from, or if you have some better way of handling your passwords inside of scripts, without that stuff, you won't be able to connect. So I put it in here in case you don't have those things. So replace this though in the script if you have a better solution, please. Obviously, this is not the most secure way of doing it, and I completely understand that. Finally, the last part of this section is simply the folders you want to write your logs and drop your report into. I have set this up in a temp folder on the C drive, so I suggest updating this accordingly as well. Okay, so next I want to look at some of the structure of the functions that we make in the script. I can't possibly go through every function detail, but they all generally follow the same format. First we're going to set up the parameters of the API call. I will pass in the API key stored from the global variable, along with any other requirement that's needed by the API, the specific API endpoint. So in this case, I'm asking ZAP to start an active scan with a previously loaded session, using the first context in that session. Now, if you set up more than one context per session, you will have to update the code to pass the parameter into the function and use the correct context accordingly. If you only set up the one context, leaving this hard-coded as one is fine. Some of the benefits of this is you can set up multiple sessions for different environments of an application. So if I wanted to set up a UAT, a QA, and a production context within one session, I can do that. But then I have to tell the script, based on which environment I want to scan, which context to use for my API calls. And an easier way is just to set up one session and one context per application, per environment, and handle selecting which one accordingly through the code. You're going to potentially run into some issues if you have, one web application doesn't have a UAT environment, or one web application maybe only have a production environment, or have, just a QA and hasn't gone to production yet. So there's some challenges there if you don't set it up one context per one session, but it's definitely doable, but just not the way we handle it. So next, we will use the requests module we loaded and call the ZAP host, which was one of the global variables we set. And then we're going to append that on the backside to the endpoint for the action we want to take. We'll then verify that the call was successful and grab the JSON return, manipulate it, and pass that back into the main code for the scan ID. This is probably because that passing of that ID to the endpoint that checks the status later on. Pretty simple, not very hard. All these functions take on the same format, so I'm not going to go through every single function. It's kind of a waste of your time, my time. But I do want to look at some of these functions in the script. The LG function will log the actions and the errors of the script for you. This is not tied to an API endpoint. but rather is the local file on the server. The next two functions are tied to the database and not the endpoints as well. The set scan state is where we set the current state of the scan to prevent scans from running over one another. The get scans do queries the database to see what's requested scans are ready to be run. And then the load session. So load session loads the session of the scan you want to run in ZAP. We then delete all the old activity, wiping the slate clean so that all the vulnerabilities that are returned are what's currently in the application. If you weren't to wipe everything, basically any old alerts would pop up. You're then grabbing those and throwing them onto a report as well, even though they may have already been mitigated. We then start the spider activity on the site. We then check continuously to make sure that spider completed, hit it 100%. We then kick off an active scan. We then continuously check to make sure that that scan has hit 100%. All while logging all of our actions throughout. So, there is various points, checks in there to make sure that the log is completing successfully. And finally, we're generating a report. Now, you can stop there, grab the report from the folder you exported, and move on with your life. But I mentioned that because of this dashboard, we created, I like to pull in the individual findings and drop them into a database. You can accomplish this with the view alerts endpoint. This returns all the details of the different parts of your alerts into an array, and you can code some logic around them to parse the data and drop those findings into a table. One thing I will note as part of this logic, you will want the script to be smart enough to close out and remove any previous findings that are no longer found. So hopefully this is because they were mitigated. Maybe a better option is to mark them for closure and then wait for a human to verify that they are closed. The other is to view all the previous findings and make sure that they're only adding results that weren't previously found. Otherwise, your table is going to double in size every scan. The one caveat to this is you may want to mark them to be new findings and not actually stick until a human has reviewed them. Because, in case there's false positives, in case there's something that, pops up that you don't need your dev teams resolving, maybe it's like an informational item only. Maybe there was an error, something that, a false positive popped up. So, I would always suggest that, before your dev team start going to work, you always have somebody on your team look at the results first, just to make sure that it's a clean report that's being given to your dev team. As we heard here over the last couple hours, the security functionality for our developers, it's not necessarily it's new, but they don't necessarily get it all, right? They're going to look at some of these findings and be like, what the heck does that mean? Which is fine. That's why we're here to help them through that. But you want to be able to clean the report up as much as possible to avoid a lot of that confusion. That's pretty much the cycle of it all. I just ran through the diagram one more time just to wrap up this talk. I have a dashboard that our technology organization has access to, and we can request scans of the applications at the click of a button. That button clicks to add records to a database, requesting that the scan kick off during the next scheduled check. I have a Windows server with the scheduled task that calls a script every couple of minutes. The script then checks the database for any new scans requested and ready for action. If it does find any, it calls out to ZAP to set up and run a scan of the application, which then delivers the findings back to the dashboard to report back to our product and tech teams the results. Now, I've provided you with the link below, a template for the script that you can customize, as well as the SQL needed to create the table for the scan request if you go that route. But that's pretty much it. Thank you for listening to me, Simon. I hope I did ZAP justice here. I left some time for any questions on this, but if there's not any, I do have a few more slides I can share that dives a little more into that open source tool and some functionality we can try to build into it. But that is it for me.
I didn't see any specific questions. If I missed something, someone go ahead and toss something in the Discord. I was thinking about, you talk about cleaning the report, right?
Yep.
You and I have had this conversation a dozen times. Triage is so important to not waste the developer's time.
Absolutely. I mean, the biggest issue, one of the things, when I first got into this role and working hand in hand with developers, before I was more on the back end side, looking at, pen testing, that type of stuff. In this role, I'm working more on the blue team, if you will, working directly with our developers, helping
Right.
them to understand, helping them to understand the findings that come out of these scans and that type of stuff, right? And it was kind of eye-opening when I talked about cross-site scripting, and I just got like a bunch of blank stares about that, right? We've talked about this, right? It was, I mean, this was probably about, I don't know, probably close to 10 years ago, but I mean, it was just like it wasn't second nature to me, but it was something that I just knew and understood. I just assumed they did because they were developers, right?
Right.
And there's so many new things that come out that, is built into the scan that, I don't know that our development teams actually know that. And that's why I'm trying to grab as much information from ZAP that basically takes that information and supplies it. So there's references to call out to. There's samples that tells you where in the code, what URLs that this finding was found under. And it's up to me or someone on my team to go out, verify that. If it is a problem, we then mark it as such, and it actually goes into the report, and it's available there on that dashboard for our teams to go and pull from. So I thought it was really that is a really good point there.
No, yeah, it's a big deal. Somebody asked what UI stack you use for your dashboard, and it's kind of cool stuff. So
so I'm like I said, I'm not a developer. Don't laugh. I've grown up on in the era of ASP and all that type of stuff, and I was a big Java developer back in the day, and so I've naturally progressed to PHP, if you will. So it's all just built on PHP, the MySQL backend. It's all used internally at our company right now today. This is something I'm looking to make public, though, to go public with, though, at some point, right?
Right.
There's a lot that's built in this tool, and I talked to you a little bit about this tool before. We have a lot of information that just in multiple areas of the business, right? We have different teams looking at different stuff.
Sure.
And we have our infrastructure guys who know everything about our servers and infrastructure. Well, we never really had that tie back publicly that the company can see of what applications those servers affected, right? And so what we did is we added this endpoint piece to it that basically our scans that go out, they go out and scan all of our production environments, our internal environments, and they pull back the names of the server, the IP addresses, what applications those run on those servers, as well as what environment they talk to, and then we look at what vulnerabilities are on that. So if I know that I have a tier 1 application, like one of our main applications that has missing patches, it has old Ubuntu, as you see here, running on it, right?
Right.
I can make that business case to say, hey, we have an application that, as a business, we're saying we're supporting at a top tier, but yet we're still running old tech debt on this, right? We have patches that we haven't patched for 5 years. Like, what's going on, guys? Right? It's very easy to have that conversation, but until I have like this data to back it up to show, hey, we have all these incidents that are popping up, over and over again, that may be tying back to, I don't know, just throwing something out there like old TLS. I don't know why that would cause incidents, but there's various things that we're building into this application to kind of like integrate, show that big picture of what's going on. We capture all the data that's in the application, and that's important because we can show then, hey, this application is international. We do have to abide by privacy laws internationally, GDPR, that type of stuff, right? Knowing that there's personal data sitting on this server, sitting in this database, yet we still are talking over TLS 1.1 is a problem, right? That's a privacy law infraction, right?
Yeah.
And one of the other things we're starting to build into this is our contracts. So we know all the contracts that we have with various customers, and we know the requirements of those contracts. So if they have like an uptime SLA availability that they require, and we're not meeting that, we have that tie back, our contracts tied back to this dashboard as well, so that we know what we need to meet in order to meet our customers' needs. One of the nice things there is, our salespeople and different people that work directly with the customers, can use this information when they go out to meet with them. Hey, we'll give you X amount of dollars to meet, 99 points, 0.0 or whatever, right? Well, we can come back and say, hey, I show here that we've never fallen below 99.8. So why don't we, for a few $1,000s more, we'll guarantee that we're going to hit 99.7, right? Yeah. So it's a tool that's not just used by our technology teams; it's used by our product teams. And the funny part was, this was a tool that I literally set up to help manage some web application scans, right? It was meant to be just used by my team, and the more people that saw it really wanted to get into it, and now we're using it to automate our ZAP scans, get those findings back. Our dev teams, or our product teams, I meet with them to kind of go over to say, hey, these are the things you need to solve in your application. This is why. It kind of helps build, like I said, that business case that we've always been missing of trying to build to get things done in security.
Yeah, along those lines, somebody made the question, do you add all applications into this portal? I think you pretty much just answered that. If not,
So,
you
yeah.
have some means to replace tools that be more fit for the purpose to aggregate reporting. Curious if you have a list of pluggable systems of record that you would integrate to the application, or there's some kind of common format. But ZAP provides the common format.
Is he talking about the applications we build or just tools that we integrate with?
Probably applications that you build.
Yeah. So right now we have all the applications we build. Well, one of the things we're also adding in here that it's not done today is like components that we build that's used across, and services that is used across multiple applications, so that we have that connection back. When we have a problem with the server, we need to reset it. We need to know what services are on that. We need to know what components are managed by it and what applications, touch that. That's something that is not very clear today. So what we're doing is we're building a separate part of this application, this tool, to have those components and tie back to the various applications. So we have a running list of all of our applications. Next thing we're going to do is get a running list of all of our services and components, and all the applications and open source that lives on those applications, and tie that all back together so that, if we ever have like an incident, a down problem, we need to reset something, we need to do something, right? We know what all is infected by that component. We know if a component is using some outdated open source software in it, we can then tie that back to the application. And again, we say that we're going to support our tier 1 applications at a certain level. I can then make the business case to show, hey, you have this component that's tied back to this tier 1 application. You need to go out and update that open source. You need to do something to fix this problem because it's providing a high risk to this tier 1 application.
Well, Michael, thank you very much for coming and speaking for us.
Sure, thank you.
I appreciate it. I didn't know this was your first
my first pandemic talk.
Well, thank you very much, sir. I appreciate you sharing that with us, and goodness, you certainly have put the time in on that piece. It's even cooler than it was when I saw it last time. So I'm very appreciative.